Good morning, grade 7s, Unit 3, Decimals and Fractions, Review, Part 2. Today, the focus is going to be more on converting from a decimal to a fraction, and also figuring out unknowns when it comes to equivalent fractions. Converting from decimals to common fractions. To convert from a terminating decimal to a common fraction, read off the place value. 0.09 is 900, so it's going to be 9 over 100. 0.271 is 271 thousandths, so it'll be 271 over 1,000. 42 and 5 hundredths is going to be 42 and 5 over 100. To convert from a repeating decimal to a common fraction, look for a pattern. And like I said in the previous slide, on page 70 in your book, you have, and it's also going to come up on this slideshow, you have some converting single digit repeating decimals with patterns. And those ones are usually with the denominator 9, 93, 30, 11, and 99 sometimes. So to convert from a repeating decimal to a common fraction, look for a pattern. So example, 0.1 repeating will equal 1 over 9. 0.2 repeating, 2 over 9. 0.3 repeating equals 3 over 9, which equals 1 over 3. So these are the patterns. So if you notice, whatever the numerator is when it's above 9, so when the denominator is 9, whatever the numerator is on top, that will be the repeating decimal, the repeating number. Converting terminating decimals to fractions, use place value. Use place value to convert the terminating decimal to a fraction with a denominator that is a power of 10, and then reduce to lowest terms. So first and foremost, you convert it to a fraction with the denominator of being a power of 10, so 10, 100, 1,000, and then you will go further and reduce it to the lowest terms, which means in simplest form or reduced form, and if it can be reduced. So 0.31 equals 31 over 100, that's it, it doesn't get reduced. 17,000, so 0.017 equals 17 over 1,000. 0.35, 35 hundredths is 35 over 100. Yes, it can be reduced. Divide both by 5. The reduced form would be 7 over 20. 125 over 1,000, so 0.125 is equal to 5 over 40, which further gets reduced to 1 over 8. And here are some questions. Show each decimal as a fraction or mixed number. Reduce if necessary. 0.261 thousandths equals 261 over 1,000. 3.03 will equal 3 and 3 over 100. 1 thousandths is 1 over 1,000. 21 and 111 thousandths, be careful, this is not repeating. There's just 3 ones in a row. A lot of students confuse this and think it's repeating. It isn't. So it equal 21 and 111 over 1,000. 1.77 repeating is going to equal 1 and 7 over 9. 1.025 equals 1 and 25 over 1,000, which equals 1 over 40. So 1 and 1 over 40, because 25 over 1,000 divided by 25 each equals 1 over 40. So F is 1 and 1 over 40. 0.005, 5 thousandths is equal to 5 over 1,000, which equals 1 over 200 in simplest form. And 0.015 equals 15 over 1,000, which equals 3 over 200 in simplest form. Number 3, 0.37. So 37 hundredths is 0.37 over 100. 100 and 1 hundredths equals 100 and 1 over 100. And 2.77 repeating is 2 and 7 over 9. Converting single-digit repeating decimals, look for patterns. So this is actually from the page I was telling you, page 70. So over here you see when the denominator is 9, whatever the numerator is, that will be the repeating decimal. Okay, so any fraction with a single-digit numerator and a denominator of 9 can be written as a repeating decimal where the numerator repeats. Okay. But when it's over 90 and the numbers are less than 9, it's going to be a repeating decimal, but there will be a 0 first. So it'll be, example, 1 over 90 will equal 0.0111 repeating. But listen, this doesn't exist when it comes to 9 over 90 or anything above 9 over 90, okay? Because example, 9 over 90 is actually going to equal 0.1. So that rule doesn't exist after that. And also when there is a denominator over 3, it's a repeating decimal and it's going up by a third, so 0.33 repeating, and then 0.666. Show each decimal as a fraction or mixed numbers. Show and reduce form when it applies. 7 thousandths equals 7 over 1,000. 2.25 equals 2 1/4 in simplest form. So 2 and 1 over 4. 0.55 repeating is 5 over 9. And 0.015 is 15 over 1,000, which equals 3 over 200. 5.05 is equal to 5 and 5 over 100, which in simplest form is 5 and 1 over 20. And 1.0909 repeating would equal 1 and 1 over 11. Again, the rule for 11 wasn't on the previous slide, but you can find it on page 70. Now, finding each unknown to make equivalent fractions. So over here, what they're asking for is, what did you multiply 2 over 5 to get 8 over 20? Okay, so 5 goes into 24 times, so the unknown would be 4. 2 times 4 is 8, 5 times 4 is 20. Same thing, 3 over 4 equals 9 over 12. What did we multiply 3 over 4 to get 9 over 12? 3 times 3 is 9, 4 times 3 is 12, so the unknown would be 3. C is the same thing as B, but they didn't put the in-between. They actually want to know what is the numerator for 4 over 7, the equivalent over 21. 7 times 3 is 21. So 4 times 3 is 12. So the unknown would be 12. 3 over 11. How much times 11 go into 66? It goes in 6. So you do 3 times 6. The unknown would be 18. And E and F, I would leave it for you guys to do. Please make sure to try them. There will be some of these on your bell work and most likely on your end of the unit assessment. Number 1, write each decimal as a fraction or mixed number in simplest form. I will do the first 2 and leave the rest for you. 0.35 is 35 over 100, which equals 7 over 20. 0.101, 101 thousandths is 101 over 1,000. So C, D, and F is for you to do. And number 2, just like the previous lesson we had, we're going to be converting the mixed numbers or the fraction into a decimal. I'll do the first 2. 7 over 1,000 equals 0.007. And B, 2 1/3 equals 2.33 repeated. So I'll leave C, D, E, F for you. And also number 3, A and B. Find out what you need to multiply by 2 and 5 to get 14 over 35. And what times 7 gives you 42? So multiply that by 3 to get the unknown above 42.